here is the black carbon in snow and ice and its impact on the cryosphere. So that is how the Arctic amplification is affected. So the black carbon and the other impurities lead to 6% albedo reduction. And regional surface warming is 0.84 degrees centigrade, and here the snowpack reduction by 11 millimeter in springtime. So this is reported here, and this is in the US region. And the second, increasing of river discharge, that happens here. And if we look at the third one, the July-September mean Arctic sea ice coverage is reduced by 3% and 1% due to the black carbon effect in 1998 and 2001. So many of these things actually talks about when there is a black carbon, that actually affects the melting of sea ice, also it affects the albedo. So here is the relationship between the soot and the Arctic surface albedo. So these are all the factors we have seen earlier, and now we are looking at the observed phenomenon or factors, how these factors are affecting the Arctic amplification as well as the albedo effects. So here is the declining trend in soot deposition, its concentration in snow and the associated forcing during 1980 to 2014. This actually suggests that the process has not been the driver for the decrease in the Arctic surface albedo and the increase in the Arctic warming. So if you look at the graph, the values are scattered throughout. So we cannot exactly say that, yeah, there is a relationship between soot and the Arctic surface albedo, but there is partly related maybe for few years, but not completely. So these are all the climate model timeline which are generally used for the studying of Arctic amplification. The first one in the 1890s, people used the radiative transfer models, and then people went to the nonlinear fluid dynamics models in the 1960s, and also hydrological cycles were developed in 1960s. Then people started looking into sea ice and the land in 1970s. And in 1990s, people started looking at the atmospheric chemistry models, because carbon dioxide, methane and those kind of greenhouse gases are included in many of the models. And in the 2000s, people started using aerosol and vegetation in the models. And recently in 2010 and other things, people started using biogeochemical cycles and carbon cycles in the study of Arctic amplification. So these are all the various changes in the climate model over the time. So these are called the energy balance models, and in 1970s people started using general circulation models, and currently we are using the earth system models. So these are some of the examples of the models used to interpret the Arctic amplification. Why Arctic amplification is important is simply because when there is a higher temperature in the Arctic region, that leads to melting of ice. Melting of ice leads to increase of sea level. That increase of sea level is going to affect the entire global oceans. So that is the reason we are worried more about what are the effects that is happening in the Arctic, which is going to be the canary for the entire rest of the world. So that's the reason we are trying to model how the Arctic amplification can be predicted.